we also have a product called AI Hub, which kind of takes in a multitude of data, is a little more focused on answering the question of once you have the data, you have an alarm, now what do you do? Kind of trying to close that loop. So trying to bring in multitudes of data for various components and track, the repair cycle and learning from looking into the damage or alert or alarm that you're getting for your wind farm.
Welcome to the Uptime Podcast. I'm your co-host, Alan Hall. I'm here with Dr. Rosemary Barnes and Joel Saxon. We got a very packed show today, probably our best show ever, actually.
Well, we're going to talk about why we keep hearing that some blackouts are looming in the United States and what we think might be some contributing factors and possibly how we can fix that. And then that will flow as well into our presidential administration engaging the Defense Production Act to inject $500 million or so into the renewable energy industry to get it moving a little bit faster.
And then I have a guest on, Megan Rotondo from Onyx Insight. We have a really in-depth conversation about blades, blade design, and predictive blade failure.
And we're going to talk about a new factory being opened up for an alternative storage technology, alternative to lithium ion. They're compressing CO2 and they've just opened their first battery facility in Sardinia, Italy.
All right, first topic, blackouts in the United States. So there's a lot of discussion on the news channels and even, especially online, there's going to be blackouts in certain parts of the United States, or at least that's a prediction. And the discussion point seems to be related around two things: climate change and renewables, solar and wind being the two primary ones, not hydro. Okay, so there's a sort of consensus brewing because of the political nature of what's happening in the States at the moment that solar and wind are going to take down the grid. Very similar to what happened in Texas during the ice storm, but this is the hotter side of that. This is a summertime case. And so, Joel, you had poked at me about this. So I went and did a bunch of research, and I went to the online resources where there's actual data, and it's a complicated mix. If you can imagine a country as large as the United States, it has 330-ish million people, and the electrical grid for such a large country, it's going to be a combination of factors, and it's not universal. It's not solar and wind. But I think some of the rationale of why they're going to have grid problems this summer should be discussed because they do need to be addressed on some level. So the middle of the United States, where you're at right now, pretty much Wisconsin all the way down to like Louisiana, is like one big electrical grid for the most part. And a lot of coal plants are coming offline. They're just going to shut them down. It's difficulty getting coal. Some of the mines are shutting down, so they're taking some it's like 2 to 3% of the production is being eliminated over time. They're also having some issues of the power lines going down. They have a major, it's like a 4-mile section of power line that went down that they need to get up and running again. But some interesting things on the western side of the United States. So the lack of snow over the wintertime hurts hydro, right? So the hydro dams don't produce as much energy. So that's affecting California and sort of the southwest of the United States. And then Texas, there's a prediction that Texas is going to be warmer, and it sounds like it's sort of headed that way right now. That's just putting additional...
It's already there, yeah.
Yeah, it's
this
already
week
there.
It's already there. It's triple digits all over the state right now, yeah.
Right. So ERCOT, who is the Texas power system, has extra power to deal with those situations in wind and solar. So wind and solar are providing the power in the afternoon and late afternoons to handle the excess demand. But also in the Midwest, there's a quasi-drought. So they're having issues of, like in the Missouri River, which is used to cool a bunch of power plants. There's not as much water in the river, so it's not as efficient to cool. So there's a variety of different reasons why the grid in the United States is having trouble. And if you can imagine, if you have power, excess power in one part of the country, you may not necessarily be able to get it to the other part of the country who needs it, just the way the grid's set up. So as we're talking about this, how do we kind of push back on this narrative of renewables are the source of all problems? Like, what are those talking points? Because like in all these situations, it's complicated. There's no one simple answer. It's not one variable.
Well, I think some of it, like if you look into the winter storm that happened in Texas, Winter Storm Uri, and you saw pictures. We talk about misinformation quite often here. You saw pictures of the frozen wind turbines, like, oh, it was all the wind turbines' fault. But if you read the reports and the root cause analysis of how some of those things happened, it was non-insulated, wellheads and natural gas lines and some other things at these power plants that went offline. So you're fighting against some misinformation there. That's one thing. But then there is also some reality to it. Distributed power to the grid, as I think we can all agree, is a good thing going forward. But we have to make sure that we can get that power to the grid, integrated into the grid, and then spread around. Right. So there's a few projects going on. I know there's a big wind farm in southern Wyoming that's been in play for 15 years, and it looks like they're finally going to get it built. But that's on the tail end of a $3 billion power line, bringing all that power from Wyoming to California, Nevada, Arizona. So that's going on. There's a couple other projects, big transmission lines connecting grids back and forth across the Rocky Mountains and some other things. So, as these coal plants and stuff, and we go through our energy transition, start to come offline, to me, I would just like to see more of the renewables, but spread out, right? If you might not have wind in central Iowa and a county north, you might not have it at that point in time. But if we can get the hybrid solution and we have some battery storage, and then we can get all those things tied into the grid in a smart way and upgrade that infrastructure, then we're on a better way to alleviating some of these, rolling blackouts and brownouts and whatnot.
Rosemary, is any grid in the world really set up to go fully renewable right now?
I think that we're getting closer to that in some parts of Australia. I mean, obviously there are some pretty close to 100% renewable grids, like in Iceland, for example, but, they're doing it a lot with anywhere that's using a lot of hydro and geothermal doesn't have these big challenges of the variable renewables grid. But the place that's furthest ahead on that is South Australia. They've got, I think, over 60% renewables, variable renewables. They've got no hydro, so it's just wind and solar. And they've reached over 60% over the last year from those sources. They're connected to the rest of the Australian grid, but still, 60% is a lot in a multi-gigawatt scale grid. It's the most in the world. And then, Australia is moving, as a whole, is moving pretty fast in that direction. And we actually have really similar challenges to what you're anticipating for this summer in the US is what we're actually right now, like as we record this, there's warnings that the next couple of days in Queensland and New South Wales that there will be a shortfall in supply if people don't either reduce their demand or if some generators don't come on. And the interesting thing about that is, usually any time there's a crisis, Conservatives will always blame renewables. And they are trying to do that this time, but it's hard because Queensland has the most coal-dominated grid out of anyone and also has the most publicly owned generation assets. And New South Wales is the second most coal. And so they're the ones that are having the problems, and the really renewable-dominated grids are not having the problems. So it's a harder message for people that want to blame this one on renewables.
Yeah. As an engineering podcast and having worked on a lot of engineering programs, you can well imagine that the engineers and the staff that are working the transmission lines and the power production facilities, regardless of what they are, all realize what the difficulties are, right? They're not oblivious to this. They push out a report every year talking about summer outages, winter outages. They're on top of the situation. But it feels like we're at the point now, we're now dealing in a larger scale. So if I'm in Missouri and I got a power plant in Missouri, can I get my power to California? No. The answer is no. You really can't. So now we're dealing with things at a national level. And if the engineers are making decisions, it seems like to me we're at the federal level now. And some recent things happen with the federal government where the president is using the Defense Production Act to throw about $500 million. And in the United States, $500 million is nothing. It's a drop on the bucket. But They're going to put some money behind solar, transformer and grid components, heat pumps, insulation, and electrolyzers for hydrogen fuel. Now, if we're really serious about having an electrical grid, handle these sort of blackout situations and getting power generation on the grid and being more distributed, Joel, where solar and wind are in more random places than a large power plant, are we ever going to get there with really a drop in the bucket in terms of finances? It doesn't seem like the federal government's on top of, we need to get transmission lines installed. We need to connect these pieces together. It's like the federal government is not listening to the engineers that are telling them what this should look like.
Yeah, reading into what you see with the Defense Production Act that Biden is encouraging now, this $545 million in funds, to me it looks like it kind of mirrors what PTC funds are in wind, right? So they can use it. They can use it to put in an order. The government can put in an order from private industry, or they can use it to subsidize via tax base or anything. It gives them the ability to do these things. But so now let's look at the offshore wind in the U.S. and how the private industry has done this. We put these bids out, and now all of these projects are inked. And what it has done is allowed people to start building Jones Act vessels and start building quayside facilities for wind, because that work is coming and that money's flowing. So if I could have a crystal ball, I would think, take this $545 million and start and do it very visibly. Make it very visible to the private markets to see, okay, the government is starting to put some cash into this, to put some money into this, to help move those things along as a small catalyst. Because $545 million, that's one, if you just said, how much money do you have? That's one wind project. Like, it's gone.
Right.
But if you could spread that out for some, some hydrogen production things and some other markets that need it, and you have it very visible, maybe it will, okay, the government is supporting this, the people are supporting this. It'll spur the private industry to kind of use it as a catalyst. And that's my best hope for it.
Well, and then there's always some piece in which the federal government has purview. There's some things that only the federal government can do. And going across state lines and putting large transmission lines in, when it comes to federal rules that are probably limiting that, they're the roadblock. And unless they're willing to do something about it, it won't change. Rosemary, I assume you have the same problem down in Australia, that the federal government says a lot of things, but when it actually comes into implementation, it seems to not be doing the work. It's like too difficult.
You know what? Until, we just had to change of government. We talked about that last time. But until that point, we had a federal government that went out of their way to not talk a lot about, anything. They certainly didn't have any bold vision for renewables. And it was the states that got on with the business of actually, announcing and doing. It's interesting. But we definitely have the same transmission issues. I think that's a worldwide problem. It's probably a good topic for another episode, actually, in depth, because there are some interesting solutions being tried to get, remove some of the obstacles to rolling out transmission fast, because it's really hard, because, you got to go through a lot of people's properties. I'm sure you have the same problem, basically, and you can't just pick and choose which ones. They've all got to link up. It's not like a wind farm where you could just, not put turbines on this person's place and put them somewhere else. You're not going to have a transmission line that snakes around to, take care of what people, which people want to be involved. But I think if it was up to me to make a big, fast change, I would put the transmission problem that needs to be solved, but I don't think it's going to be fast, even if you could solve the, human element. I'd be working on which parts of the network are struggling and helping them to install a lot more rooftop solar or community batteries, so that they didn't always need as much transmission into or out of that area. To me, that would be by far the fastest way to make a big impact. And I know that there are big differences in how much rooftop solar costs in Australia compared to the US. I think it's twice as much in the US, and in Australia permitting will take 1 day, and in the US it's commonly 6 months. So there are definitely some bureaucratic things that, would be perfect for a government, even a local government. I think it's local government that causes a lot of these issues in the US. If you want to solve your your city's energy problems, then help people to get solar cheaper. And like the doubling in cost between Australia and the US, it's not because we pay half as much for our solar panels. It's because we pay half as much for, all of the soft costs, everything else. So I think that would be a really fast way you can make a difference in 1 year, if you really got stuck into it.
Well, I think we're going to come back to this transmission line, how we're going to support the grid. That's going to have to be a topic of conversation because we're kind of getting toward the breaking point here, and it doesn't feel like there is very little movement on it. So let's hit it as
I think
one
I
of the topics in the
know
next couple of weeks.
somebody working on that. Maybe we could interview.
Yeah, that would be fantastic. We're going to take a short break right here, and after the break, we're going to have Megan Rotondo, Service Development Manager of Onyx Insight. And Megan is a blade expert and also a blade sort of diagnosis expert. She's actually taking data from all kinds of wind turbines and putting brain power to it to do predictive failure modes, which is really interesting. So after the break, Megan Rotondo of Onyx Insight.
Ping Monitor is a continuous blade monitoring system which allows wind farm operators to stay ahead of maintenance. Wind techs can often hear damaged blades from the ground, but they can't continuously monitor all the turbines. They also can't calculate how bad the damage is or how fast it's propagating based on sound, but Ping can. Ping's acoustic system is being used on over 600 turbines worldwide. It allows operators to discover damage before it gets expensive and prioritize maintenance needs across their fleet, and it pays for itself the first time it identifies serious damage or saves you from doing an unnecessary visual inspection. Stop flying blind out there. Get Ping's ears on your turbines. Learn more at pingmonitor.co.
Hey, Megan, thanks for being on the show. Megan Rotondo, everybody, from Onyx Insight. And Megan, you're a service development manager at Onyx Insight with a really deep expertise in blade design. And we had talked previously about all the things you've done, and it's remarkable, actually. You have done a lot of interesting blade things. And I get asked all the time about, hey, what do I need to do to get into wind? Or if I want to design blades, what do I need to do? And I think your background is really ideal because it explains sort of the pieces you have to put together to be really good at designing blades. So, Megan, welcome to the program.
Thanks for having me.
So did you just give us a brief background of just your work experience and what your educational experiences are?
Sure. Yeah, I come from the engineering world. So I went to Cornell and graduated with a master's of engineering in mechanical engineering, but my original undergrad was in civil. So I was always interested in structures and how to design, big civil structures. But also while at school, I was on a project team that builds race cars. And so naturally, being on a project team, you work with composites. Usually in the racing space, it's carbon fiber composites. So that's where I learned a little bit about composites and got pretty interested in them. So when you take my degree in kind of big civil structures and composites, the natural progression was to look at wind turbine blades. That's how I really started into looking at wind turbine blades, is in my master's program. And in the US, one of the biggest OEMs in wind turbines is GE. So immediately kind of started looking at that and ended up at GE in a leadership program. And that's where, my entire career has started and ended up in, renewable energy, and more specifically in blades due to my interest in composites. And from there, I stayed in renewable energy. I worked for a Chinese OEM who has a design office in the US. And after that, got an itch to kind of look at the operations and maintenance space outside of, kind of the original design, kind of complete the life cycle of the product. And I moved to Onyx Insight in the beginning of 2021 to start looking at the operations and maintenance for blades, damages, how to maintain them, how to repair them, and anything that could go wrong with a blade.
So you just started as a civil engineer, decided to be a mechanical engineer, got interested in composites. You start working in blades, which is actually a very typical story, and that they kind of find their way into blades and wind energy and really stick with it. But that means probably changing jobs a couple of times and doing a little bit of moving around and taking on support tasks and just learning from the ground up. And that eventually leads you into the role you're in, which is more of a predictive maintenance RCA type role. And now at Onyx Insight, which if you're not familiar with Onyx Insight, it's a predictive maintenance company essentially. And as everybody knows, has been doing a lot of things in drivetrain for a long time. So you walk into Onyx Insight, but Onyx Insight already does condition monitoring, right? They have just a whole plethora of options there. You want to describe sort of what Onyx Insight does?
So Onyx is an interesting company. Yeah, as you mentioned, they come out of drivetrain. So vibration-based monitoring using accelerometers. It's a pretty established field in most industries, but at the time when they'd come in is a little bit new for wind. And Onyx has kind of got three parts to it. It has the hardware side, so our products like EcoCMS or EcoPitch, which are actually the physical hardware needed to monitor your gearbox, main bearing generator, and similar with EcoPitch to monitor pitch bearings. So there's the physical hardware development that's owned by Onyx. And then of course with that, there's software. So in order you can't just have the hardware, you need to take in the data and analyze it. So Onyx has our own software platforms to do a multitude of things. Related to the drivetrain monitoring, there's a software to look at the analytics coming in from the accelerometer data, so the vibration data, manipulate it and be able to trend it, alarms. And we also have a product called AI Hub, which kind of takes in a multitude of data, is a little more focused on answering the question of once you have the data, you have an alarm, now what do you do? Kind of trying to close that loop. So trying to bring in multitudes of data for various components and track, the repair cycle and learning from looking into the damage or alert or alarm that you're getting for your wind farm. We also have Field Pro, which is like an inspection software, so that actually, mobile device, you're out in the field as a tech, doing an inspection. This came out of just the way Onyx works. It's kind of coming out of customer issues. So naturally, if you're getting alerts about your gearbox, you need to go do a borescope inspection. It was difficult to get, quick data, or you have a turbine, you have a tech up tower, and you need to get some good data. So that was kind of built out of just being able to use your cell phone and have an app to take data and go through the tower and upload things to a database, and it would come directly back to the engineers. So that's the software side. And then the engineering side, which is where I sit at Onyx. So the company was really built out of design engineers originally from, the drivetrain side. And that's the basis for Onyx. We're not just a sensor company or a hardware company or just a software company with really good, development or analytics. We have wind turbine engineers in-house because we want to first develop the software that and hardware that actually solves problems. It's not just a nifty piece of hardware or software. And then also you can dive into the physics of the problem. So you're not just looking at the high level data or analytics, you're actually understanding why these problems occur, and that adds that extra level to the analysis and vibration analysis that they did originally. And now we're expanding, and I'll get into that because, I do blades. But yeah, you kind of have to have that background. So you're not just saying that there's an alarm or an alert. You now have that extra level that Onyx can provide of, we've seen a lot of these. This is what this type of failure looks like, and this is what we recommend you do because of it. So that's where it comes into blades. So Onyx is looking into kind of full turbine condition monitoring. And as always, we start with engineering. So I joined to bring the blades expertise. We have electrical expertise in-house now, and tower and foundation expertise as well, and pitch bearings, of course.
As one of the blade experts, and you just have a tremendous amount of experience, everybody knows, or pretty much everybody today is using drone data. And what you get is just a whole lot of pictures. And sometimes they're spliced together, sometimes they're not. It depends on who's doing the project, actually. And from that, it just is overwhelming, right? It's just a lot of data. But are you able to sort of manipulate that data and look at it at a sort of a top level and say, hey, these are the kind of things we're looking for. These kind of blades have these issues, and we're trying to just track like crack progression or even leading edge erosion. How does that fit into the AI Hub world?
So currently, it can bring in kind of the blade data that is coming from a drone inspection company. Usually focused on those that you want to repair. The other piece that we're looking at, which is more of a high level, so currently right now, although I'd love to get crack progression in AI Hub, currently right now it's looking at a little bit more high level. So looking at maybe an aggregation. So part of AI Hub has like a data exploration space where you could bring in more of the high level data. So looking at maybe number of turbines or amount of number of blades that have damages or the amount of damages on those blades tied with maybe some SCADA data or number of emergency stops that were on that turbine. That's more of the data exploration space. And that's more of a high level. There are definitely some more detailed analysis on that crack progression level or trending, which is not currently fit into AI Hub. It's a lot of players in the space don't know yet what to do with all this data. There's a lot of really good data out there. I mean, the industry has now been doing drone inspections for about 5 years, and along with those images is coming that metadata, which is where you'll find the length and width and location and defect type and surface of the blade. And that data is just massive. And the problem with that data is it's very dirty data, for lack of a better word. It's subjective a lot of times. So one company or even person within a company looking at that data will say it's a severity 3. And then another company will say it's severity 4. And then, the owner operator goes in and changes it to a severity 2. So there's a lot of variation in that. There's also variation in the location. So it may say 1 year it's at 27 meters along the blade span. And then the next year, the same company, the same drone, just from, I guess, errors in the location of, where the drone is and how it's sizing it, it'll say it's at 27.8 meters. Also sizing. Sometimes when you draw the box around the crack, you may say, oh, well, there's a bunch of little ones. We'll just draw a big box. That's one defect. And then the next year, someone's like, you know what? These are all little cracks. I'm going to draw 5 little boxes. So if you're trying to compare, how did that crack progress just on a data level? So you're not physically, because you want to look at 100 cracks. So you're not going to look through each image. You want to do some data analysis. You want to do some trending. That's going to confuse the trending because it'll say that you had one large crack, even though, there's nothing to tell you that there's multiple cracks in there. Versus, next year it turned into 10 small cracks. So it's really hard. You have to think of clever ways to normalize that data. You can try to do this on area or kind of, where it's located. You have tolerances to handle the span location issue. So there's a lot that can be done, but I think the industry hasn't quite cleaned up the data enough to move forward with that like really detailed crack progression.
Yeah, it's very manually intensive work to do. And so is the key then really standardization? I know that has popped up a lot in the last year or so, just describing what damage is and everybody using the same definition of damage. There is no standard right now, and which makes it hard, right? I mean, how do you have predictive tools if you don't have the underlying data and consistency in that data? And what do we do about it?
That's a great question. And I think coming in from design and my engineering background, design engineering, I was all for a standard. I was like, we should have a standard. This makes sense. When, a crack is a crack. We should have a standard. I think looking at the damages and actually being in the industry and really thinking about it a little more deeply, I think it's more difficult than it seems at surface level. Because of the way blades are designed. Blades are designed with loads envelopes, and even those envelopes are statistically determined. So there's a lot of probability and estimations. And then sites, are sited based on their own load envelope, which is determined by MetMast. And again, this is wind, so tons of variability. So you may take one turbine with one loads envelope. This is just one piece of puzzle. You're going to put it at your site, and that blade is going to see its site-specific loads. And of course, that site, site A over here, just made the load envelope. Like it's got a little bit of margin, and it's just fitting. So it's seeing pretty high loads for its design. The next site, they have a little bit of margin. The wind doesn't have as much variability. There's as much turbulence. But it made sense to site and put that same exact turbine and blade design over here at site B. So then if those two blades have a crack that's of similar size in a similar location, so a standard would say, okay, you have a trailing edge transverse crack on your, manufacturer A turbine, which were designed to class, 3 low, all these standards that we work off of. You have these two sites, site A and site B. If you standardize it, you would say, either always repair when it reaches 100 millimeters or, let it go until it reaches 300 millimeters. If you try to set this generic standard, what I could definitely see happen based on, how these blades are designed and how composites work is site A, doesn't repair it because that's what, our standard came up with. And then it progresses immediately to a half a meter crack, major damage. And then site B doesn't repair it and it doesn't really grow. Maybe in 3 years they get to it and it's no big deal. And this is the same blade, the same crack. So when you think through this logically, as this is what I want to standardize, it's totally different growth rates. So there's so much challenge and nuance and detail when you start diving in to the actual workflow of what happens in these decisions and the physics of where turbines and blades are sited, the different load variability, the different fatigue cycles they see. It makes it more challenging. I think to some level, some kind of standard would be helpful. But I can see where it will just cause more problems to try to be rigid.
From an outsider's viewpoint, that all seems crazy, right? That basically every blade is its own living, breathing thing. And it needs its own separate diagnosis almost. But when you see a crack on a blade, it's not the same as in Colorado, it's not the same as Massachusetts. They're just not going to be the same result. And so how does that drive then? I mean, how do you then incorporate that into a sort of predictive model? Is there even a way to do that, or we just need a lot of smart people like you looking at a lot of photos to figure out what ought to happen next?
There's definitely stuff, more standardization and more analysis we can do on a high level to help with predictive maintenance using lots and lots of data and kind of establishing baselines in terms of what regions on certain models and certain areas, you can try to aggregate if you have enough data and provide kind of some baseline of experience. So I think that data analysis is still very important. But then there's always that second layer. I think there always will be an engineer who needs to look at that and make sure that makes sense. Trying to, go at least for your own farm, establish, your risk tolerance, what makes sense, for your site and your risk level, and then kind of start tracking your data and targeting in on a few key issues. So there's different ways of looking at this, and I think it's site specific and owner operator specific.
So is the key then consistent monitoring? And blades are weird, right? Because there really is no active blade monitoring today. There's nothing inside the blades telling you about the structure at all, at least not on a large scale. So is it then every year, particularly early on, you need to be doing some drone inspections of every blade? Is that where it needs to go? Just so when you get to years 5, 6, 8, 10, where it really starts to matter, you have this progression? Because without having that initial data, you don't want to start at year 5, right? I mean, you just lose the progression, which is what you're using to do your analysis with.
Yeah, and it's kind of a hot topic because there's pros and cons, and it's that typical, like optimization problem where if you do too many repairs too early, you're kind of spending too much money on that repair. And then if you're waiting until you get, a catastrophic failure, you're going to spend way too much money because you've let it go too long. The tricky thing is finding that middle point. So it really does depend, and that's where the high level analytics can help. So understanding just generally, what's the load level, what's the site level from the get-go? Are you at a highly loaded site? Lots of turbulence intensity, lots of precipitation for erosion, having kind of failure, just general failure rates, which Onyx does a little bit of work in as well. Just understanding from a really high level what's the failure rate based on certain site conditions or turbine models or design types. Understanding what those failure modes are from a high level may determine when you start your initial inspection. I think within the warranty period, it's good to have a baseline, but you shouldn't be seeing, unless there's some major design issue, you're really not going to be seeing, those little cracks that are going to grow throughout the lifetime, starting from year 1. What I'm kind of learning and gaining from the industry is seeing that year 5 is when you may start to see things pick up, and year 10 is definitely when you're going to be seeing that the smaller cracks starting to progress on a fatigue basis that you can maybe trend and take a look at. So it really depends on if you're concerned, you've seen, that that blade have a certain failure on someone else's farm, or you're concerned about the manufacturing quality because you did an assessment and the factory wasn't up to, high standards. Then you may want to start your inspections early to catch any kind of design or manufacturing issue that would happen early in its life.
No, that's really important, right? You're bringing this whole bunch of information to all the listeners out there. This kind of data isn't readily available to a lot of people, so it only comes through experience, right? So where does this all get hashed out at? Where does the industry sit down with itself and say, you know what? You need to be doing a third of your farm every year scans. And that's the industry standard. Who leads that conversation? Where does that happen at?
Oh, I wish I knew. Most people would look to the certification bodies to lead that. No matter who leads the effort, it's going to need to be from those who deal with operations and maintenance. So the owner and operator who carry a lot of the risk, and I think the OEMs who have, they also carry risk and do service contracts could provide valuable insight as well to the maintenance. But either way, I think it probably will need to be led from, an independent kind of standpoint. So a certification body who deals with multitudes of every owner operator, every OEM to kind of lead this effort, and then bringing in the input from basically everyone who has to deal with that. So all the ISPs like Onyx and various others who assess the damages should be involved, as well as obviously the owner operators who have to repair those damages. The whole industry needs to come together, but it is tricky because it is valuable data. It takes a lot of work and a lot of money and resources to get that data. So I don't think it's going to be easy. I don't think it's going to be easy to have, even if it was through someone like a certification body, to bring all this together. I know there's been attempts to do that, usually on a regional basis. I know the EU has a program that's looking at cost of maintenance, and they have an independent service provider leading that. just based on government grants. And in the U.S., organizations, nonprofit or independent organizations, research institutions have led a couple of these efforts, and probably in other parts of the world as well. So I think on a regional basis, it's a little bit easier to kind of narrow in and look at it, but it is difficult because you can't force everybody to come to the table and give up their data.
Right. And is it giving up data, or is it really just setting that sort of baseline? And there's a big difference between those two, right? I mean, you're not giving anything away. You say, every 3 years you need to be inspecting your turbines. That's not deep information, right? If it was, hey, these Siemens blades have an issue when they have wind gusts of X, that's a little deeper, right? That's way down into the noise. And yeah, I would consider that to be sort of private information. But I mean, we just don't need to have that sort of basic infrastructure for people like you to know what we're looking at, right? Because if you're missing data, it's really hard for you to help, right? You need data to be useful to the operators.
Yeah, and that's why we try to work with as many customers as possible to understand it from a broader. That's a benefit, honestly, of being in an ISP independent. Is you're not stuck with one fleet. It's great to see what's happening across the industry and globally too. So understanding what's happening in various turbines. And that's definitely it's difficult though, because even something as simple as that, you can probably do only a third a year on your younger turbines, may not be applicable to some models, so yeah, it's a very high level approach, and that's, I think, how the industry has gotten where they've gotten to, which is pretty much each owner operator decides on their own, to the best of their ability, what they want to do, and they reach out to various companies like Onyx or any other ISP and who deals with blades and kind of says, this is what I'm doing, and then we say, oh yeah, that's a great idea, or they may come to us saying, this is what we're doing and we're having a lot of failures, or this is what we're doing and our budget is super high. We want to figure out how to make it, we want to optimize this. We want to reduce our blade maintenance budget. And it's very specific. So it could be beneficial to have a standard that's the high level. And, and I think that's where people like to have some kind of baseline is a good recommendation. But then when it comes down to it for your site, you're probably going to have to optimize if you want to, maximize the amount of, performance and minimize the downtime and extract all the value that you can. You will have to be site specific.
Yeah, I mean, that's a very interesting viewpoint of it. And obviously, because you get to see a variety of different turbines and turbine problems, and you get to see U.S. and outside the U.S. what's happening, you have a very unique perspective on it. And I think this is where Onyx Insight adds a lot of value. Is it just because it's not tied to a particular operator or OEM, you guys get to see everything. And that's the benefit. And when we all show up at the same conferences, so we're at conferences and we're all kind of battling back and forth a little bit. It does seem to revolve around just consistency, just being consistent. And let's try to raise the bar a little bit for an industry. I know, and everybody's working hard to do that, but sometimes we don't really set that floor. We don't really share a lot of information, so it makes it hard to do that. And we need a lot of people, more people like you, Megan. Honestly, is that when you bring a lot of expertise to the conversation, and that makes the discussions that much more focused and enjoyable as an engineer. I mean, those top level sort of discussions around the edges don't really matter. If we're talking about really trying to reduce cost, then we need engineers deeply involved that actually know something and have firsthand experience to come back and say, Alan, that's crazy, or yeah, that's great. We should be doing more of that. And this is why we want to have people like you in the program, which is why you're here today, is that we're trying to get this message out to people like, hey, there are so many brilliant engineers working on these really difficult problems, way deeper than we would really think about. And it takes that sort of expertise in companies like Onyx Insight. They're going to be making the difference of a renewable future. It's the way it is.
operations and maintenance has so much opportunity, and especially in blades. There's a lot of smart people out there trying to figure out what we should do to just minimize this. Blade repair budgets have ballooned, and it's just because we need to really understand what's happening out there and dive a little deeper than just the high level. Oh, we just we wait till a blade falls off, or we're repairing every crack. So there's a lot of nuance in there.
Yeah, we've heard those conversations, and it's a little scary, but yeah, we've heard that because it is a way. It is one way to manage it. Maybe not the way I would manage it, but it is a way to manage it. And Onyx is growing, right? So Onyx Insight is actually. How many engineers work there right now? Or how many people are working at Onyx right now?
A little over 100. We might even have crossed the 120 mark at this point, because we also have, we have monitoring engineers and, consulting engineers, and then software developers, so software engineers. So there's a lot in the works, but Onyx is definitely growing. And blades, we're looking for good blade engineers, because they are a very hot topic, and we have a lot of blades work.
And you're based in Colorado. Is Onyx Insight just in Colorado?
No, we have offices globally. So we're, Colorado is our U.S. office, and then we're headquartered in Nottingham in the U.K. And we also have offices in Spain, Korea, Australia, China. We cover all the regions. So it's a truly global company.
So if I'm a blade engineer and I want to get to Onyx Insight, I want to reach out to Megan. Megan, how do people find you?
Through our website is a really good way. So yeah, you can just go to onyxinsight.com and reach out to contact us, and our sales team and sales engineers will definitely get you in touch with myself, or any of our other engineers across the globe for any issues that you may have, blades or otherwise.
Megan, this has been a great discussion today. I really appreciate you having me on the program, and let's stay in touch, because I know these blade issues are going to continue on, and as the industry evolves, I want to get your feedback on how things are going. So it's really great to have you in the program today.
Thank you so much for inviting me. This was an awesome opportunity.
Lightning may be a force majeure, but lightning damage isn't. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS, so you can stop worrying about lightning damage to your blades. Visit weatherguardwind.com to learn more, read a case study, and schedule a call. WeatherGuard is proud to be engineer-owned and operated in the USA.
So big thanks to Megan Rotondo of Onyx Insight. Great amount of information from Megan, and we'll have Megan back on the show hopefully soon. Switching subjects slightly, because Rosemary brought up the discussion of localized energy storage. There's a company called Energy Dome, and if you haven't seen this online, there's some YouTube videos showing how this works. But they're basically created a CO2 battery storage facility. So they are just completing a facility in Sardinia, Italy. It's a 20 megawatt, 200 megawatt hour installation. And it's going to be fully functional by 2023, but it's up and running at this point. And it's a system that can store energy for up to 10 hours at roughly half the cost of lithium-ion batteries. And it's a closed-loop system. So, Joel, what they do is they take carbon dioxide, they compress it, they cool it, they turn it into a liquid, they put it in storage tanks. That's the storage part. When they want to use that stored energy, they expand it back up through a turbine. It spins a turbine to make electricity. Therefore, you have a closed system storage battery that's not chemically based, so to speak, like a lithium ion, but it's actually sort of physical gas compression. Was it a gas cycle, essentially? Yeah, it's a gas cycle system. And the reason I bring it up is that, like Rosemary was saying, like in the United States, we need to have local energy storage to handle these ups and downs of the grid. How do you do that quickly? I don't know if there's enough capacity in the world to build batteries fast enough to have localized energy storage. But carbon dioxide is everywhere. We could build carbon dioxide storage area. Right. Yeah, right. Right. Joel, does this make any sense, particularly in a country as big as the U.S.?
Yeah, there's a couple of things I really like about it. One of them being this technology isn't all brand new. right? These
Oh,
processes
true.
or these individual processes are known, but they've, conglomerated them into a novel process to do this battery storage. So there's no bottlenecks for development. We understand how to do it already. And of course, like you said, we're not going to have to mine something or anything like this. CO2
Right.
is readily available. And I think it could be expanded to different types of gases as well. But
Sure.
so I like that side of it. I think the other thing I'd like to see, and this is an energy storage issue, I think, across the industry. I think we have to get away from calling them batteries. And the reason being is battery from a technical sense works. But when you're talking to the general public, they think of battery as something that's a physical, like a lithium ion battery. Like when someone says battery
Right.
storage, if I say battery storage to a guy down the street, he thinks of how many, Duracell D-size batteries can you put in one building? So I like I really like the concept here, but I don't like CO2 battery. I like CO2 energy storage facility, and I think that would do better for it. But as it sits, they say it's ready to go, and we can install it in large quantities. The supply chain is, or large capacities. So the supply chain is there. The technology's developed. I say we hit the ground running with it.
Rosemary, Australia has probably already built similar things to this. I know pumped hydro is the great savior in Australia, and rightly so. It's pretty simple, right? You pump water up, you store energy in the water because of gravity, and then you let it come back down and create electricity again. So it is a quote unquote, like Joel was saying, it is a battery, or more like an energy storage system. It's pretty effective, isn't it? It seems simple enough.
Yeah, I mean, this is one of the areas that I work on a lot with my consulting company, Partalute Consulting, and I look at a lot of the different options that you have, and also sometimes I'm designing systems for people that have a big off-grid project, energy intensive project. So it's really interesting, like, to compare when you look, on paper at what a system, systems pros and cons are compared to when you actually try and integrate it. And when I'm designing something, I always end up either recommending lithium ion batteries if it's relatively short duration storage needed, and pumped hydro if the terrain allows, and if it's longer duration storage that's needed, or like overall system reliability, because they're just much, much cheaper. So I know that this Energy Dome says it'll be half the storage cost of lithium ion battery, but let's wait and see. But I do note that there are plenty of auctions for storage durations, storage projects with durations similar to that, especially in California. There's been a lot recently, and lithium ion battery projects have won those. It's a reverse auction, so they're bidding in the cheapest for even at least 8 hours now. In nearly every case, there has been occasionally some alternative technologies that make it to the last little bit, but there's nothing stopping Energy Dome from bidding on these projects. And if they could really come in at half the cost of lithium ion, then they would be winning them. So I say I'm skeptical about that. The problem with like Joel said, I like this technology because it uses a lot of aspects, like not new aspects. Like we've been able to compress and uncompress fluids for a long time. Compressed air energy storage is one that's fairly mature, fairly mainstream, and the CO2 version has some advantages relative to that in terms of the density of the energy that's stored, but they do suffer from low efficiency compared to a lithium ion battery. Will be around 90% pumped hydro, at least above 80%, and compressed fluids. When you actually see working systems and take real data, it's quite a lot less than that so far. But there is scope to improve it somewhat. But again, like if you're using mature technologies, then you've got less scope to make massive improvements in technology. So, I think it'll be useful for places where you can't have pumped hydro, and if we do see lithium ion prices continue to increase from supply chain problems, then I think we'll need a variety, and this would be one of the potential ones that could find a fairly big niche.
I was just thinking as you were speaking there, Rosemary, of and this is expanding the topic a little bit, but I've been talking with quite a few people involved in the carbon sequestration, storage, CO2 over here in the United States. And I'm thinking about, this is 20 megawatt, 200 megawatt hour plant, can supply, storage for 8 hours. What if we expanded this thing on a grand scale to the point where we're using the compressed gas that's stored in a salt dome under the surface of the Earth, and all of a sudden this is turned into a 500 megawatt facility, right? It's just a thought if it's doable or not.
We do things big in America.
Yeah, they are doing that with compressed air. There are some projects where they plan to use a salt cavern as their storage, and definitely for hydrogen, that's one of the leading ways that people are planning to store long durations of energy. But just on the Energy Dome website, and they've got 66.7 kilowatt hours per cubic meter. So you can see, from that how much space you would need for how much energy. And I don't know if you actually asked it, but I thought you were going to ask if it could be, like a way of sequestering CO2 out of the atmosphere. And for that, I would expect that it's not going to be a meaningful amount of CO2 sequestration. But I definitely hope that they, take it from the atmosphere rather than making it specifically for this purpose.
Right.
That would be a good use for some of the CO2 from direct air capture. But I don't think it'll be a lot.
Active projects of that sort, right? You guys have heard of Air Products, right? They supply gases and air for all over the place. They've got a $4.5 billion project going on in Louisiana right now. That is going to be CO2 sequestration, hydrogen storage, salt dome, all of these things that we just spoke of, and the DOE's behind that one as well. But it's $4.5 billion for a development of this sort.
Well, I was just listening over the weekend to a firm that makes diamonds, artificial diamonds, but they're using CO2 pulled from the air. That was their claim to fame. So they're using CO2 pulled from Climeworks, and then they put it into their little diamond making machine to make artificial diamonds that are pretty close to mined diamonds. And they consider themselves to be carbon negative, right? So they're pulling carbon out of the atmosphere and turning it into diamonds. That was why it was a green technology. That cannot be, right? How much energy do you must need to make something so hot and apply so much pressure to turn carbon into diamond, make C13 is what, C13, C14? That can't be energy neutral at the least. It may be carbon negative, maybe, but it's not energy. And it just seems weird to hear some of these things pop up because...
but you've really hit the nail on the head for the problem with the vast majority of these trendy carbon uses, that they add so much energy use to, and even direct air capture, like the amount of energy that you need to do it. You can source it from renewables, but you could also, we don't have enough renewables to do all the things we really need with it.
Saying.
And I mean, my biggest thing with the diamond capture is, we need to remove gigatons of CO2 from the atmosphere, and there's a reason why we measure diamonds in carats and not gigatons.
That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening, and we'll see you here next week on the Uptime Wind Energy Podcast.
Get the latest on wind industry news, business, and technology sent straight to you every week. Sign up for the Uptime Tech newsletter at weatherguardwind.com/news.